Alright folks, so we're going to discuss a confidence interval for the population mean today. In the previous videos, we motivated why we need a new distribution, the t-distribution, and we saw some examples of how to use the t-table. So we're going to need that t-table today, but not quite in this video because I'm just going to show you the formula for this confidence interval. So recall we are estimating the population mean, and it starts out with the sample mean. But that is just a point estimate. Remember, we called that a point estimate of mu. Point estimate for mu. And we're going to carefully construct an interval around x bar. This is going to be the margin of error. And that margin of error, this is some interesting notation here, but we'll explain it again. So in the subscript of this t, I am writing df for degrees of freedom. And that tells you what row to use in the t-table. And we're also using alpha. Alpha is this fishy looking Greek letter. Alpha over 2. That is an area in the tails of the t-distribution, but it's split between the two tails. So that was called the t-critical value. T-critical. But this t-critical is also going to be multiplied by the standard error. We saw sigma over square root of n, but this actually says s. Right? That was one of the whole reasons why we're now in the t-distribution instead of the z-distribution. So this is the standard error. In total, everything that's after the plus and minus sign, this whole value is called margin of error. And maybe I will abbreviate that. I'm going to call it MOE, M-O-E, for margin of error. I would like to make a sort of glossary of terms here, so you've got all your notes in one place. I want to remind us what degrees of freedom is. Recall, degrees of freedom, it's just sample size minus 1. No big deal. The next item here I would like to list is alpha. It looks like a little fish, but that's a Greek letter alpha. This is called the significance level. The significance level is usually a small number because it's an area in the far tails of a distribution. So alpha is usually a number like 0.01, 0.05, or 0.10. So I want to draw a picture to help illustrate this. If this was a t-distribution with some degrees of freedom, zeros in the middle, alpha is typically a small area in the tails. But because it's in the two tails symmetrically, I'm not going to label this alpha, but it's going to be alpha split in half. And recall that the t-critical value from the previous video, it's the distinguishing tick mark right here that defines that region. Furthermore, recall the total area under these density curves is 1. So if we know the area in the tails, it's usually some small proportion, then we also know the area sort of in that center. That would be the complement. And that's the confidence level. Because confidence and significance are complementary, If you know one, you know the other. So the confidence level is typically 90%, 95%, or 99%. And we can label that in our nice picture over here. I'll label this confidence. Maybe I won't be able to fit it, so I'm just going to write conf. And I'll underline it in green over here. What confidence refers to, it is the proportion of random samples in which the associated confidence interval will contain this parameter that we are estimating. So it is usually a larger percentage or proportion because we want to capture our confidence, or we want to capture our parameter in this interval most of the time. So that is the formula that we're going to use for this chapter, and in the next video we will see a couple examples of how to use it. So get your T tables out.